Good morning, everybody. We're going to start revising differentiation, chapter 12, SL, IBSL. Okay, this question now. It's past paper question including 17 marks. A greenhouse is made in the shape of a half cylinder. It's constructed from a galvanized steel frame with multi-wall polycarbonate sheeting. The steel frame consists of rectangular base, 4 semicircular arcs, and 3 further support rods, as shown in the following diagram. The semicircular arcs each have radius r, and the support rods each have length L. Let S be the total length of the steel used in the frame of this greenhouse, and we need to write expression for S in terms of R, L, and by. To do this, now we're gonna start the first part of our question. The circumcircular arcs each have radius r, and the support rods each have length L. So this is R, 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 and R, L, L. Let S be the total length of the steel used in the frame of the greenhouse. Write down an expression for us in terms of R, L, and by. And to do this, we need to know where is the S in this 3D shape. We have it first all here. We have 2 from L, so I'm going to say 2L, plus 4 from R, so I'm going to say it's 4R. Still, we have another L here. See if you can see this chord, and this one, and this one. So I'm going to say it's 3L, plus the half of the circle, which is this arc. And if I'll find the circumference of the circle, it becomes C equal to 2 by R squared. Because I want half of this one, it will become by R. So each arc will be 1 by R. But because we have 4 arcs, I'm going to count it as a 4 by R. If I want to simplify it more, I'm going to get 5L plus 4R plus 4 by R. Okay. To continue my question now, I want to go to the second part. In the second part, they are asking me if the volume of the greenhouse is 37.5 meter cube. We need to write an expression in terms of R, L, and by to represent this volume. So we know that the volume equal cross-section multiplied by the length. So in this case, the volume, which is 37.5, it will be the cross-section, which is half of the circle. So it's half by R squared multiplied by this length, which is L. So to represent now the volume, I'm going to say it's 37.5 equal half by R squared multiplied by L. And this is the expression what will represent for me the volume. Okay, I'm going to go for the second part or the third part in this question. In the third part, they want me to prove that S equal 375 over by R squared plus 4 multiplied by 1 by multiplied by R. Okay. First of all, if you can see in this equation, we don't have any more L. So in this case, I'm going to go back for this equation and put L alone to one side. I'm going to multiply 37.5 by 2. 37.5 multiplied by 2. So I'm going to get it equal to 75. So 75 now divided by R squared, I'm going to get L. So instead of the L in this expression now, in this equation now, here, I'm going to write S equal to 2 multiplied by 75 over by R squared plus 4R. It's 5. In this case, I'm going to go for this part. 5 multiplied by the 75 over by R squared plus 4R plus 4 by R. And if I'll simplify it more, I'm going to get 75 multiplied by 5. I'm going to get 375 over by R squared plus 4. I can take it as a common factor here. And also R, I can take it as a common factor and write it 1 plus by inside the brackets. You can take R to the other side also. Okay, we're done with part C in our question. Now we need to go for part D. They are asking me to find the derivative of S function in terms of r. So what I'm gonna do in this case, I'm gonna put r up, so it will be s equal to 375 over pi multiplied by r to the power of -2 plus 4 plus 1 plus pi multiplied by r. R here, it's to the power of -2 because I need it in terms of r. So in this case, if I want to find the derivative of s in this case in terms of r, I'm gonna multiply this part by -2. So I'm gonna get it equal to -750 over pi, and r, it will become to the power of -3. And in this case, r to the power of 1. So I'm gonna multiply all of this by 1. I'm gonna get 4 multiplied by 1 plus pi. So this is the derivative of s over r. Okay, we're done with this part. I'm going for the next part now. The greenhouse is designed so that the length of the steel used its frame is a minimum. If the length of the steel is the minimum, so in this case ds over dr will be equal to 0. So if I want to solve this, I'm gonna say -750 over pi r to the power of -3 plus 4, 1 plus pi, it will equal to 0. And if I'll solve all of this in terms of r, I'm gonna get at the end r equal to 2.43 meter. I'm done with this part. So I'm gonna get now the minimum of the steel when r is equal to 2.43. Okay, I'm gonna go for the next part. They want me now to calculate L for which S is the minimum. L, when S is the minimum, this means I need to replace R in this function. I want to find L, okay, when S is the minimum, so R is the smallest amount here, which is equal to 2.43. So I'm gonna write L equal to 75 over pi multiplied by 2.43 to the power of 2. And in this case, I'm gonna get L equal to 4.04 meter. I'm done with this part now. Okay, in the next part, they are asking me to calculate the minimum of S. Now, I need to calculate the minimum value of S. To get the minimum value of S, I know that S is equal to 5 multiplied by L and 4 multiplied by R and 4 pi multiplied by R. So in this case, I need to replace the new value of L, what we got from the previous question, which is equal to 4.04. And I need to replace R also, which is equal to 2.43. So I'm going to say now 5 multiplied by 4.04 plus 4 multiplied by 2.43 plus 4 multiplied by pi multiplied by the new R, which is 2.43. And if I want to get S in this case, it will become equal to 60.5 meters. And that's it for this question. Thank you. Good morning, everybody. We're going to start another question. Here we have 16 marks. For a homework assignment, Tiffany makes a cylinder out of paper with a volume of exactly 200 centimeter cube. To make the curved surface of the cylinder, Tiffany cuts a rectangular shape from a standard A4 sheet of paper, A4 dimensions 21 centimeter width and 29.7 centimeter length. The circumference of the cylinder base, the length of the rectangular cut, is denoted as an x centimeter, and the height of the cylinder, the width of the rectangular cut, is denoted as an y centimeter. Using the formula for the volume of the cylinder, find an expression of the width of the rectangular cut y in terms of x. First of all, we know that the circumference of this curved shape or the circle, it will be x. So in this case, x equal to 2 pi r. So if I want to find r in terms of x, I'm going to say it's x over 2 pi. I'm going to get r. This will lead me to get y from the given volume. We know that the volume of this cylinder, it will be pi r squared multiplying by this y. And now, if they give me that the volume equal to 200, so it will equal to pi multiplied by r squared, what we found before, which is x over 2 pi, all of this squared multiplied by y. And if I want to simplify my work more, I'm going to get 200 equal to by x squared over 4 by squared multiplied by y. We can cancel one of the by's here, and we need to simplify my work. I'm going to get 4 multiplied by 200, it will become 800, and still we have by here, and I need to divide by x squared to get y alone equal to what? So we wrote now, in term of x, we got y. I'm going for the second part of my question. State whether x can have a value of 2 centimeters. If we will get x equal to 2 centimeters, I need to get value, but this value, remember, I needed less than the 29.7 what they give me in the question, okay? Because they said here, state whether x here, less than 29.7. So I need to replace it in this function. Sorry, I need to get y less than 29.7. I need to replace x by 2. If I will replace x by 2, I'm going to get 800 by multiply over 4 equal to y. And if I solve for this one, I'm going to get the answer equal to 628. 628 centimeter. And in this case, 628 centimeter, it's greater than 29.7 centimeter, which is not acceptable. It can't be equal to 2x in this case. Okay, I'm going for the next part of my question. In the next part, show that the curved surface area of the cylinder, in this case, the curved surface area, and if you can see here that the curved surface area, it's given in this area, which is x multiplied by y, okay? So we need to show that the curved surface area of the cylinder can be expressed in terms of x as a equal to 800 by over x centimeter squared. And if I want to get this, I need to say a equal to x multiplied by y, and they said in terms of x, so I need to represent y here by the value what we got already before, which is 800 by over x squared. And if I want to simplify my work more, I'm going to get it equal to 800 by over x. So this is to write this area in terms of x. And we're done with this part. I'm going for the next part in my question. They asked me to find the derivative of this a in terms of x. To find the derivative of this one, I need to put x up. So I'm going to get 800 by x to the power of -1. And if I want to find the derivative of this one, it will be -800 by multiplied by x to the power of -2. So this is the answer of the derivative of this a. You can rewrite it again. It'll become -800 by over x to the power of 2. So this is another way to write the derivative. In the next part also, they want me calculate the value of x that minimize the curved surface area of the cylinder. If I want to minimize this one, I need to put this one equal to 0, the area equal to 0. So in this case, I'm going to say 0 equal to -800 by over x squared. But to get this means x equal to 0, while x can't equal to 0. So in this case, I can't say x equal to 0. It's not equal to 0. If I want to sketch this one to describe my situation, I'm going to say there is relation here. A, it will decrease when x, it will increase. Okay, so in this case, I can't find x equal to 0. Okay, so x in this case, it can't equal to 0. That's why I'm going to say that x is equal to 21, which is given in the question. And if I want to replace x by 21, I'm going to get it y equal to 800 by over 21 to the power of 2, and to find this value, I'm going to get y equal to 5.70 centimeter. And this is what I'm going to use for the next question. Calculate the minimum curved surface area of the cylinder. The minimum curved surface area, it will be represented by x times y. And in this case, as what we said, x can't be equal to 0, so I'm going to use 21. And I need to multiply it by the new y, what I got, which is 5.70 0 after rounding, or you can use the original of this point. So you're gonna get it equal to 120 centimeters squared. And that's it. Thank you.